Today we'll be talking about chi-square, and it will be our last class. Now, when do we use chi-square? Chi-square, when you want to talk about the, okay, now you have two groups. We have group A and group B. If you want to check if there is any association between group A and group B, we use chi-square. Remember I said you are a data analyst, and as a data analyst, people will be coming with their problem. So you have to know various statistical tools, and you'll be the one to prescribe the right statistical tool to solve their problem. So if they come with a problem of testing if the average of a particular product is a particular value, like the average lifespan of electric bulb is 100, we know we are going to use t-test. If they have two groups, they want to compare them if they are similar or not, we know we have to use t-test. If they have more than two groups, we know we use ANOVA. If they're talking about getting a model that will explain the relationship between variables, we are talking about regression. Now we have different types of regression, but so far we've limited ourselves to ordinary least square regression. If they are talking about three groups, we have ANOVA. Then if they are blocked, we talk about two-way ANOVA. If we want to know the combined effect of the factor and the block, we can talk about two-way ANOVA with interaction. So for chi-square, if we're talking about association, on that keyword is independence and dependence, depending on how you want to put it. So I can say group A is associated with group B, or there's an association between group A and group B. When there's an association, another way of saying it is that group A depends on group B, or group A is not independent of group B. So I've mentioned three keywords: association, dependence, independence. So that's what we use for chi-square. So when someone comes to you and tell you, I have a research I want to work on, I'm trying to see if sex has anything to do with contraction of COVID-19. Is it that male are more prone to contract COVID-19? Or is it that female are more prone to have COVID-19? In such situation, they are talking about what? If there's any association between two groups. If group A depends on group B, or if group A is independent of group B. So we know that we are going to use chi-square. So you have to know all these statistical tools, so that you have to be conversant with them, so that you can prescribe the right statistical tool to use for your work. So that's it. So let me create. When we talk about chi-square, we have different tests in chi-square. We have chi-square goodness of fit, we have chi-square test for association, and we have chi-square test for equality. What we are only learning is chi-square test for association. We are not, what chi-square goodness of fit is used to test for the distribution of the data sets. So we can use it to test if the data follows the Poisson distribution, if the data follows the gamma distribution, if the data follows binomial distribution. So we can use chi-square goodness of fit. We have chi-square test for equality. If we want to test if the frequency are distributed equally among different levels of a group, we can use chi-square test for equality. But we are not talking about these two tests. We are talking about chi-square test for association, or chi-square test for independence, or chi-square test for dependence. If you watch what so far I've been talking about three keywords: association, dependence, independence. So let's start. Let me look for a data set that we can use for this. I don't know if we have any data set so far here. Let me look at this set 6. Let me look at set. Okay, let me look at US arrest. If we can use it. Our lights and run. No. Now, chi-square goodness of fit, we use, you take note that we work with the frequency. We use frequency to determine if there's any association between both. So the example so far that I have in mind that I gave, if sex has anything to do with, if sex has anything to do with contraction of COVID-19. Okay, let me create data set for myself by myself. So I can create a, let me sample. Let me see if this will work. Yes. No. 40 times. Let me see if it will work. Sorry. So they asked me to include replace. Replace, you can spell through. I'm trying to get the data set. So let me look for what my data set is saying. So correct. So I have data set. So I can call this COVID-19. COVID-19. So the question is if they have COVID-19, if they tested positive to COVID-19. So what I did here is I'm sampling. The function is sample. I'm sampling between yes and no. Replacement is true. I didn't include it before. So that's why I got the error message. Replacement true means I'm sampling with replacement. Let me explain. We have two types of, okay. I talk about sampling with replacement and sampling without replacement. I want to talk about sampling without replacement. So if I have a box and I want to select randomly from the box, so let's say I have 6 balls. So if I select box 2 first time, if I don't return it back to the box, that's sampling without replacement. But if after selecting, I take note of the number, I replace it and select again, that's sampling with replacement. Now, if you are sampling with replacement, it's possible for you to get a particular number or string or character many times. So that's why I have yes. So the first time I selected yes. Second time I selected yes. Third time I selected yes. Fourth time I selected yes. Fifth time yes before no. Now, if I want to get consistent results, remember I've taught you this, you have to set seed. If you don't set seed, you won't be getting consistent results. Let me show you what I mean. If I run this again, take note of the results, it will not be the same. I seen now the first time I selected is no. Why is it so? Because I'm selecting randomly. So every time I run the code, it will select afresh. I start from beginning to select, and it's not possible for you to, if I ask to select 20 balls today, tomorrow I ask to select 20 balls tomorrow. Like tomorrow I ask to select 20 balls again. I don't expect you to get the same result you got yesterday. So that's what is happening. But if you set seed, it's as if you have a particular repository you are selecting your balls from, you always get the same result. Now, like I've already explained set seed in our previous videos. You can put any number you want. There's no rules. People use ones, people you can use 16. I can use any number I want. Now, if I use this, whenever I run the analysis, I will always get the same result. Take note, let me run it. So look at the result. So let me run it again. You will discover I'm getting the same result. So that's the essence of setting my speed. I think like the same thing. So let me set it so that I can always replicate my result. So I've simulated data for COVID-19. Let me simulate for gender. I'll also sample from male, female. Let me 40 times replacement. Replace should be true and sampling with replacement. Let me select my seed before I run everything so that I will get consistent, the same results. So let me see what I have in gender. So this is what I have. So let me bring both of them together and call it, let me call it set. We have set 9, so let me call it set 10. So I want to bring them as a data frame COVID-19 and gender. So let's see what we have here. Correct. So now we have the female. The first person that we tested is a female. She doesn't have COVID-19, tested negative for COVID-19. The second person, male, tested positive. The next person, female, tested positive, female positive. So we are trying to, looking at this result, we have a research hypothesis. Is it that there is association between gender and testing positive to COVID-19? Is there any association? Is it that gender and COVID-19, they are independent of each other? Or do they have any thing in common? So that's chi-square test for association. Now, how do we do this? Very simple. The code is chi CHISQ.test. So chi-square. You put your first group, which is COVID-19. Okay. Set $10 COVID-19. My second group, set $10 gender. That's all. Remember, I simulated data, so I'm not expecting to get good results. But this is how to do it. If you want to see the tabular expression of your, like how many numbers you have, the frequency, number of male, number of female, if you want to see that, you can use table 10, set 10, COVID-19. The function I'm using now is table. Take note, table is the function. So I want to get the contingency table, call it contingency table. When you see the result, you understand better. So look at what I mean. This is a 2x2 contingency table. So we have number of females that tested negative, they are 9. Number of males that tested negative, they are 9. Number of females that tested positive, they are 12. And number of males that tested positive, they are 10. So that's what we have here. So it's like, remember I simulated my data. So I'm not expecting to get perfect result because they are not real life data. Let me increase the sample size and see if we'll get something different. Let me increase the sample size to 100. So in this case, we have 2x2. We have is a 2x2 contingency table. I can have more than 2 groups. No, let me start with set C, so I'll get consistent results. Let me see the table. Still giving me some almost similar results. I want something that is different. Let me change it to 500 and change that to 500. I want something different. And also, let me change this set C. Let me use 3. Okay. But they are still close. Okay, let me have 3 groups. Okay, we can still continue with this. Now, so we have 2 groups. Let's interpret the 2 groups first, then we'll interpret for 3 groups. So this is your contingency table, 2x2 contingency table. So you can include it in your results. I've taught everyone how to copy this, how to copy to Excel. And from Excel, you copy to Word. So I've taught everyone how to do this. So let me show you how to interpret your chi-square now. Correct. So the null hypothesis is there is no association. That's null hypothesis. Why the alternative hypothesis is there is an association. Remember, null hypothesis is there is no association. Alternative hypothesis is there is an association. So when we say there is no association, it means they are what? Independent. No association is equal to what? Them being independent, equal to what? They are not dependent. No association equal to not dependent. No. Yes, not dependent equal to independent. No association equal to not dependent equal to independent. The alternative hypothesis is there is an association. It means they are not independent. It means they are what? Dependent. Take note of the 3 keywords. Now, you reject your null hypothesis when your p-value is less than your level of significance. I've explained what level of significance is. is your probability of committing type 1 error. What's type 1 error? When you are rejecting a true null hypothesis, when the null hypothesis is actually true, but because your sample size was not correct, or maybe the method you use was not correct, or the sample size was not correct, something was wrong, and you rejected it, so you committed type 1 error. Now, the probability of committing that error is what we call level of significance. So I've explained before, you can use different values, and now you can check our previous video. I talked about the rule of thumb that I was told by a lecturer, a professor, that we can use. So basically, for this class, we'll be using 0.05. So whenever this value is less than 0.05, we reject the null hypothesis. Rejecting the null hypothesis means we are going with the alternative hypothesis. But whenever it is greater, it means we are not rejecting the null hypothesis. That means we are going with the null hypothesis. So based on this work, we can make our conclusion. Remember, null hypothesis is that there is no association. We can make our conclusion that we don't have any sufficient proof or any sufficient evidence to show that there is an association. That's what I'm concluding. I don't have any sufficient evidence to say there is an association. Because the p-value is greater than 0.05. It means I'm not rejecting my null hypothesis. Times I don't have any sufficient evidence to say there's no association. So if you want to interpret this, you want to do a complete work, how will you do that? If you want to do a complete work, how will you do that? First, you have to state your null hypothesis, that there is no association. You state your alternative hypothesis. You state your level of significance. Then you copy your contingency table. Maybe you can write a note that you talk about. This is below is my contingency table, and you explain the number of male that tested positive to COVID-19, which is this number of male that tested positive to COVID-19 is 119. Number of male that tested negative 124. You can also interpret for female, number of female that tested positive and number of female that tested negative. So you can do that. Then after interpreting, you can talk about the chi-square results. Then you use the p-value to make your decision. You talk about decision, reject your null hypothesis when your p-value is less than 0.05. Then you talk about your conclusion. In the conclusion, I'm not going to reject the null hypothesis since I don't have sufficient evidence to show that there is an association between both. So I'm making my conclusion that gender and COVID-19 are not dependent. I mean, they are independent. So that's what the result is saying. Now let's do another work where we have three different groups. Let's talk about religion and country. So let me talk about religion. Okay, let me talk about religion and gender. So we have Christianity, we have the Islam religion, we have the traditional religion. So we have three groups for religion. I'm setting my seed at 3. So this is my table. No. I have to change this. We don't have COVID-19 again. So what we have here is religion. I can delete this. Let me run it. What we have here is religion. What we have here is religion. So this is my table. So we have a 3x2 contingency table. 3x2 contingency table. So look at the p-value. We are also not rejecting the null hypothesis. That means we don't have any evidence to show that there's an association between gender and religion. So that's a result of this. Very simple. So I believe we all understood what I explained about chi-square. I believe so. If you want to copy your results, let me just show it once more. If you want to copy this table, you just highlight, take it to Excel, paste it, go to, it won't paste as table. Then you go to data, go to text to column. You can use the default or you could use the delimited. Then you direct arrow, we have to, Excel, we have to put the border. So I can say use space for border. Are you seeing it? Use space for border. Now take note, didn't arrange it well. So I'll be the one to arrange it myself. So I have to move this. Look at that, I'm moving it. Correct. So I can put my border. You have to learn how to arrange your work. I can put my border. Some people can, the way you arrange your work is different. One, you can decide to do all border, though I don't do this. What I do is I put border in top, put border in bottom and top. I like this and put in top. So this is what I will do. Let me show you print. So this is how I arrange my. So this is how I arrange my. That's how I arrange my own. So this is how I arrange my results. So it's your choice, depending on how you want to arrange it. So let's go back to R. So we've learned, we're done with chi-square. We're done with chi-square. Now someone asked me a question about Laplace, apply. So let me address it here. And we'll know what next to treat. Now, let's use our empty cars. These are empty cars. Empty cars. Now, in empty cars, we have different variables. Different variables. So let me select. Let's say we want to look for the mean of all these variables. The mean of MPG, CYL, TIXP, HP, DRAT. We want to look for the mean or want to look for the maximum value for all the different variables. Now, because you are working with different variables in a data set, different variables in a data set, you can use either Laplace, apply, or supply. Now, Laplace will bring your result as a list. Supply will not bring your result as a list. Supply and apply. When I talk supply, this is what I mean. Look at the screen. This is supply. Apply means we have apply and we have Laplace. Laplace will bring your result as a list. So let's start with Laplace. So you click Laplace. Then you select your data set, which is empty cars. Then what do you want to do? I want the maximum. So I want the maximum for all the groups. So that's it. Are you seeing that my result came out as a list? I've explained what list is in our first class. If you want to look for the minimum, you change your function, minimum. Now, if you are using supply, your result will not come out as list. Are you seeing the difference between apply and supply? They give the same result. Like look at this, cap is 1, cap is still 1. But supply doesn't bring your result as list. Apply and supply bring result the same way. If you are using apply, then you have to state, in apply, you have to state, are you working with the row or column? So you write your empty cars. Row is 1, column is 2. So I'm working with column, all the different columns. The columns, that's 2. What I want is minimum. So that's different between apply, supply. I think that apply and supply will bring the result the same way. When apply will give you the opportunity to select whether you want to work with row or you want to work with the columns. So because if I want to work with the row, I will select 1. That's how it is. So I've explained. So this is just to address a question someone asked. Okay, let me also address something. Let's go back to our empty cars. If you want to arrange your work, let's say you have a result like this, and you want to arrange it you want to arrange them based on MPG in ascending order. In ascending order. So that's what you want. So how will you do that? Take note of the first number here, the first name here, which is Mazda. If after arranging it in ascending order, Mazda may no longer be the first name there. So this is how to arrange it in ascending order. Empty cars, you put your block brackets, then you write order. order. Then what do you want to use to order? Remember, let me explain something. When you put these block brackets, you know you have to select both row. You have to input what you want in your row and column. You have to, when you put your comma, what should come before the comma is for row, what will come after the comma is for column. Now take note, what you are sorting is the row. You are sorting the row. You are sorting the row to know they want to arrange them in ascending order. So that's why I will write it here. I will not write anything in column because I'm not touching the column. So order, what do you want to order? I want to order empty cars. Let me see if I don't put empty cars, it will work. MPG. Let me see something. Okay. So I want to order empty cars, MPG. Now this is for the row. For column, I'm leaving it empty means I'm working with everything. But if I don't want to work with everything, it means I want only the first 4 columns. First 5, then I can indicate it here. But let me start with everything. Look at this. Are you seeing that MPG has been arranged in ascending order? If you don't want to, if it's not MPG, you want to arrange in ascending, you want another one, you can arrange it in ascending order. And take note, each row we go with their value. That means if 10.4 is coming up, it will go with the CYF value for it, the DISP value for it, HP value for it. So this is how to order data sets. This is how to order data sets. I think we are done with chi-square. Then I've been able to address some things. If you have any question, you can do well to reach me on WhatsApp. Contact me. Let me just do summary of function. If I want to write a function for summation, function. Remember, I told you when you want to write function, you start with function. Just simple example. You put your variable here. So let's say I want to sum 2 numbers. So I can put x1, x2. This, what you put inside the bracket are what will be changing. What will be changing. Then you put your curly brackets, you click enter. Then you write the function that you want this summation to be doing. The task that you want summation to be doing. What I want summation to be doing. So let me call it summing. I don't want to use summation again, and I don't want to use sum. Why I don't want to use like I can just want to write any name I want. Let me use SUMM. The reason why I'm avoiding sum is a function, is a default function. That's why I don't want to use sum. And also, since I'm naming the function I'm writing summation, I don't also want to use it. So what is this? It means x1. Anything I type in x1, add it to x2. Then when you are done with this, you return your results. What will I return? So, okay, there's something I have to explain here. Let me run this first. So this is how to write functions, simple way. Then if you want to make use of it, now I've created a function that arrow knows, my own arrow knows. Look at it, it's stored in my global environment. So whenever I click it, it tell me input value for x1, I put 2. Input value for x2, I put 10. The result will be 12. It means to add 10 and 2. Look at it, 12. Now, what if I want my result to come out with more details, not just 12? Like I want something like the sum of 2 and 10 is 12. That's how I want my result to come out. How will I do it? I can write another line to this my function. So let me call it results. Now, because I want to have enough details, I want to have enough details in my results. So what will I will use the function called space. What do we use space for? We use it for concatenation, to concatenate different things together. We use it for concatenation, to concatenate things together. So look at what I will do. The sum of, I will put comma. Now the first thing that they are strings value, so that's why they're in quotes. The sum of comma, what will be next? Any value that is I type in x1. So anything I type in x1 should come next, comma. Then this will always come out, and anything that is in x2 is the final answer. So this is how the result will come. Anytime I run this analysis, space is to concatenate it. It will be the sum of x1 and anything that is x2 is the actual result. So let's see how it will be now. Now, what I will return is what I will return is not sum again. What I will return is the result. Return means what will come out as your final answer. Are you seeing it? The sum of 2 and 10 is 12. The sum of 2 and 10 is 12. So we use space to concatenate things together. Now, I want to explain something. Look at this. I separated all this using what? Comma, comma. Now, arrow, the final result will bring them together. Arrow will use space to concatenate everything. What I mean is, look at the first statement, the sum of arrow will combine this and this using space. Are you seeing the space? Now, what if I don't want space? I don't want to use space to concatenate it. Then I have to change the default. Then I have to set it as separate. That's SEP. What do you want to use? Maybe if I want, look at the default now. This is what arrow used in space. If I don't want space, I will clear the space. Let me run it. You will see there will be no space again. Are you seeing that there's no space? So arrow use the default. What if I want more than one space? I can set it. Are you seeing it? What if I want underscore to be used? I can set it also. I see it. So depending on what you want to use. So this is how to write your function. Simple way of writing your function. So I've taught this. So I believe the only thing new will be this space function, which is used to concatenate. Now remember, I've told you always go to your help. So you can go to your question mark, paste to know more about it. So look at it, used to concatenate strings. Look at the default is separate using space. That's the default. But whenever you want to change it, you can change it. Whenever you want to change it, you can change it. So that's very simple. So I think we've come to the end of this class. Any other method you want to learn, you can easily get the code online, read about it, and get the code online. Okay, so that's all. Thank you all. Had a nice time with everyone. You can still go online, download manuals, and read more about arrow programming. I believe so far what we've done, you should have a lot of knowledge on arrow programming and you should be conversant with arrow programming. I think I've treated all the basics and I've moved from basics to some of the advanced things we do in arrow programming. So it's not just the basics we have here. We've moved to some of the advanced things we have in arrow programming. So the next thing you have taught you also how to get any code, any code you want to learn. So now all you have to do is to know different methods. I just taught few methods. So you can decide to learn more about ARIMA. We have different methods. We have millions, thousands, hundreds of thousands of methods in statistics. So we have VAR model, ARIMA model, AMA model, MA model, R model. We have the GASH model, many models. We have the ridge regression, partial least square, so all those things. If you want any of them, just go online. For example, if I want the code for principal, let me use on GASH model. I can just type GASH model R in arrow. So that's how to get it. You get the code. You can open one or two. And as if you already know what GASH model is. You can open one or two. You will surely see the code, and the code will not be much. So these are explanations on GASH model, but the arrow code will not be much. So look at the libraries you need. The libraries you need. This is your data set. So get data from this. So this is it. I've taught you edge. This is a plot. That's it. So look at all the codes. Very simple. You should be able to know what all these things mean. So this is square root. There are times you need to standard deviation. You should know what all this is. So this is your Gash model. So this is the Gash model. So any code you want to learn, just one or two lines, few lines. So I've taught you all the basics. So we're going to have NGAF for this training. But whenever you have any challenge in R programming, do well to contact me. Now it was a nice time learning with everyone, yeah? And God bless you all. Thank you.